Good morning to all. This session is in continuation with the previous session. There we started discussing various kinds of systems under systems of part 2 of unit 1. Now in the previous session we already given the description and definition of linear systems and non-linear systems. So here one more time just we are remembering those 2 points, then immediately we will start how to recognize or prove a system is linear or non-linear. These two are very much important. Let us start. Let us start. Now, let us start this one. In the previous session, we started linear systems and non-linear systems. Linear systems and non-linear systems. Now, whether it is linear or non-linear, two important points are to be verified. One is whether the given signals are under superposition condition or not. Second one, these given signals are homogeneous or not. These two are to be, we have to verify. Once these two are verified, then only just we have to enter into whether the system is linear or non-linear. Now let us start. For example, look at first question. Verify that whether the given signal x of t, the given signal is x. The given signal is x. Verify this is linear system or non-linear system. Now first just look at, for your understanding purpose, let us begin with x square. Linear system or non-linear system. Now as for this one, first step is to create two different signals. Two different signals from the given signal. Now, these two signals will be x1 of t that is equal to x square. That means x1 square. x2 t, this is equal to x2 square. These two are two different signals. Okay? Now, for the given input x1t, let y1 of t is the output, y1 of t. Do one thing directly. Now, let us create two signals. What are these two signals? x1 of t, x2 of t are two signals. Now, these two are what? Inputs. These two are inputs. Now, let the outputs be y1 of t is equal to some transformation of x1 of t. Then the output gives what? x1 square. Look at some transformation. For the second one, the input is what? x2 of t. The corresponding output y2 of t. This y2 of t is some transformation of x2 of t. Now let its output be x2 of square. Now just look at, a signal is given. From that signal we assumed two inputs. For each input there is a corresponding output. x2 input, corresponding output. In this one, how the response output, this is transformation of the input that is equal to output. Y2 is what? Transformation of the input, that is the output. x2t, not 1, x2t square. Now just look at. Here, what is the linear property? Now we have to verify what is the linear property. Linear property is what? That is, linear property is transformation of superposition signal A1 of x1t, A2 of x2t. This should be equal to constant into transformation of x1 of t plus A2 times transformation of x2t. Now, this is called linear property. This is called linear property. This property is to be satisfied. So now look at whatever have we written within the curl brace of this. This is called superposition signal. This is superposition signal. That is means what? Sum of transformations. That means what? Transformation of the entire signal, or you have to remember transformation of sum of signals equal to sum of transformation of signals. Look at the linear property. Transformation of sum of signals should be equal to sum of transformation of signals. This property is called linear property. Very important. Transformation of sum of signals should be equal to sum of transformation of signals. Here just look at, we are taking transformation of the entire signal. In the previous class we discussed x1t is a signal, individual signal, x2 is individual signal, but a1 x1t and a2 x2t for two constants a1, a2. Entire thing is a single signal. Now, transformation of sum of signals is equal to sum of transformation of individual signals. This is the correct point of linear property. Linear property. So now here again I will explain. Just look at, because this topic is very much important. Here in this topic, each and every concept should be understood properly. To discuss whether a system is linear system or non-linear system, first what we explained, first we have to verify superposition rule or condition. The second concept is called homogeneity principle. The second concept, that is called homogeneity principle. First, these two should be verified. Once verified, then we have to go for principle of linearity or linear principle or linearity principle. Next step, just we have to verify linearity principle. Linearity principle. Now just look at, in the linearity principle, what is happening? Linearity principle means what? A signal x of t will be given. From this signal, create two different signals, x1 of 2, x2 of t. These two are inputs. We have to find corresponding outputs for the signal x1t. Let y1 of t is the output. Let y2 of t be the output. Now, how the output will give? Y1 of t equal to some transformation of the input signal x1 of t. Now, what is y2 of t? that is equal to transformation of the input signal x2 of t. Now just look at, for our understanding purpose, for the input signal x1, output is y1. For the input signal x2, output is y2. Now, what is linearity property? Again, I am explaining before solving the problem. Linearity principle is that if x1 of t, x2 of t are two individual signals and a1 and a2 are two non-zero constants, then a1 x1 of t and a2 x2 of t, these two are two different signals. Now sum of these two signals a1 x1 of t plus a2 x2 of t is a superposition signal. This is a superposition signal. Superposition signal. Once this condition is satisfied, then these two are of same degree, because look at here, all should be the same degree. Then homogeneity principle will be satisfied. Now, after that, we have to verify that linearity principle, L stands for linearity. Linearity of the superposition signal a1 x1 of t plus a2 x2 of t, superposition signal should be equal to individually a1 L of x1 of t plus a2 L of x2 of t. That means what? a1. What is L of x1 of t? y1 of t. That is equal to a1 y1 of t plus a2 of y2 of t. Now this is the superposition principle, this is the linearity principle. Again, in a single capsule, how to remember the linearity principle? That means what? Transformation of sum of signals, transformation of sum of signals should be equal to sum of transformation of signals, sum of transformation of signals. This principle is very easy to remember. Every student has to remember this principle. Just look at here, two words we are using, transformation and sum. These two are swapped here. Transformation of sum equal to sum of transformations. Now just look at here, we are taking only single transformation of the entire signal. Single transformation of the entire signal equal to sum of individual transformations. Look at, this is transformation 1, this is transformation 2. But here we are using only one transformation. That thing students have to remember. That's why we are making it as transformation of sum of two signals is equal to sum of two individual transformations. This is first transformation, this is second transformation. So this is the way. So regarding this one, linear system position, students have to understand that three positions, three important points we have to cover. The first one is superposition, next one is homogeneity. After that, we are discussing principle of linearity or linear principle, linearity principle. In this principle, which condition are we following is equal to transformation of sum of individual signals is equal to sum of transformation of individual signals. It is very, very important. Now in the very next session, we are going to prove whether a system is linear or non-linear. It is a mathematically we have to prove it. From this mathematical proof, just we have to apply these three conditions. These problems seem to be a little more than small, but we have to analyze it. Thank you.